Strengthening mechanisms. In the Introduction to Materials module, we talked about dislocations being present in metals. These dislocations reduce the strength of the metal. The principle of strengthening mechanisms is to reduce the ability of these dislocations to move through the metal. This can be achieved by the reduction in grain size, cold working, solid solution strengthening, and dispersion or precipitation strengthening. These strengthening mechanisms can be applied individually or in combination. In metal, it is estimated that there are 10 million to 1 billion dislocations per centimetre squared, and each dislocation has a strain field associated with it. With grain size, the grains can interact with the dislocations, preventing further movement of them. If we reduce the grain size, we can increase the number of grains interacting with the dislocations, preventing their movement and thus strengthening the metal. Cold work introduces a large amount of strain into the metal. This strain interacts with the dislocation's strain field, impeding the movement of the dislocations. Solid solution strengthening is applied when we add other chemical elements to a metal. As discussed in the Introduction of Materials module, the elements added can either fall between the atoms of the bulk material or replace the atoms. Within steel, carbon atoms fall between iron atoms and nickel atoms replace iron atoms. This will either be called interstitial or substitutional solid solution strengthening and will cause distortion in the atomic structure. This distortion interacts with the dislocations, preventing the dislocation movement and strengthening the steel. Dispersion or precipitation strengthening is highly related to the structure of the metal and takes place when a phase is finely precipitated through a softer matrix. This hard precipitate acts as a barrier to dislocation movement. The precipitates can also produce a strain field that interacts with the dislocation strain field.